Hello everyone. Our first example of dynamics is going to be pretty straightforward. This example only has one force that they're talking about on the question, so I don't tend to draw force diagrams when we're only referring to one force. When you read some of the other examples, you'll see that we'll include a few more forces on it, and then I will start to draw some force diagrams. If you are having a tough time with vector type questions and dynamics are vectors, it really helps to draw a quick diagram, label the forces and the directions of them, because you'll see with the examples that I do, when you're calculating net force, which is probably one of the most important skills in this course, whether it's net force using kinematics and dynamics, or whether it's calculating net force using the Physics 30 formulas I'm going to show you, it is going to be very important that you understand to calculate a net force. It's going to be finding the sum or difference of the forces depending on the directions they're acting on. And then once you know the net force, you will use Newton's second law, which is probably one of the most famous formulas in physics and one of the most often used: acceleration equals F net over mass. So this is going to be a question that uses it, but it's pretty straightforward. One thing that I am going to start stressing to you in this lesson is that when you have many different numbers being given, start to label them off to the side, start putting what you know and what you don't know down so that you could go starting to look for an appropriate formula. Kinematics and dynamics formulas can be used in many different types of questions together, so it's starting to get a little bigger formula list that we have to choose from. So bullets start with a speed of 0, so initially I'm going to label my initial velocity here 0 meters per second. Obtain a maximum speed of 745, so my final velocity 745 meters per second. Travel through a rifle barrel that is 1.1 meters long, so we have a displacement here of 1.1 meters. Notice I'm putting everything in the proper units as I write them down. It says determine the magnitude of the force, so we want to know the force that's being applied. I just use FA for applied force. Some of your previous physics instructors may use T or just F. Really, it's just kind of a subscript for the force, just so that you understand what the force is. This is the applied force, or average force on the object is what we're looking for. And they give us the mass in grams. So I'm going to change that to kilograms right now. I know that 1.1 gram, or 11.3 grams, is 11.3 times 10 to the negative 3 kilograms. So I'll change that to the proper units right off the bat. Now, since we're looking for force, we're not looking for gravitational force, so we can eliminate those FG formulas, and there's 3 of them on the formula sheet. There's a force of friction formula. We're not talking about force of friction on here. We're not talking about the force of a spring. So whenever they're talking about a net force or just a force being applied on here, we're going to use this formula off our sheet. Acceleration equals F net. This is Newton's second law divided by mass. And since there's only one force acting on this object, we just have to find, basically in this question, the one missing piece of this, the acceleration. If I can figure out acceleration, then I can go and find F net, because this equation 1 will become F net equals mass times acceleration. Now, unfortunately, I don't have a formula for acceleration right in here. I can't use this formula yet. I don't know F net. I don't know A. So I have to go back to my formula sheet, look for a formula in kinematics from the last lesson that uses VI, VF, and D to find acceleration. And I hope you look at this formula, VF squared equals VI squared plus 2AD, and use this formula to find acceleration. Now, since the VI is 0, that makes this term and this formula a little easier to manipulate. So VF squared equals 2AD. Manipulate that for acceleration by dividing both sides by 2D. So acceleration equals VF squared divided by 2D. Now here's where you have a couple options. You could do a substitution at this point, find acceleration, then take that number and put it into equation 1. But remember, in physics we want to keep our numbers exact as often as possible. If you're pretty decent with your algebra skills, what you can do is substitute equations into each other. Since I know what A stands for, I can substitute, and this is something you're going to see me do quite a bit, substitute equation 2 into equation 1. And what we're going to create is one single formula that I only have to put the numbers into once. And that's it. Now, do you have to do this step? Of course not. You can work out the acceleration, keep that value exactly on your calculator, then go work out the net force. I'm just going to save myself one step so that I can write this as F net equals mass, and for acceleration I'm going to put in VF squared over 2D, and it'll be one substitution. When the formulas get really large, maybe I might work them out separately, but if you had a couple simple formulas like what these are, then it's pretty easy to drop one into another and only do one single substitution. If you put your numbers in, F net equals the mass 11.3 times 10 to the negative 3 kilograms, and we're going to multiply it by, and this is just one big calculator punching in now, 745 meters per second squared over 2 times 1.1 meters. And it's just a matter of entering this into your calculator correctly now. And really, because it's one big multiplication operation, you just have to make sure that you square the 745. And the other trick to this, depending on the type of calculator you're using, you always have to, when you have more than one number in the denominator, you need to use brackets for it. So depending on how well you are at punching things in on your calculator, you could do this in one single step, or you could do this in a series of steps. And I'd like you to try it maybe a couple ways so that you understand how your calculator works properly. What I would do is punch in 11.3 times 10 to the negative 3 times 745 squared. Then I would hit my divide and then use a bracket symbol and go 2 times 1.1, close the bracket, so that your calculator knows it does the operation on the top and divide by the multiplication on the bottom. If you forget the brackets, you will get the wrong answer. You should get a final answer of 2,850.8. And if we go back to the number of sig digs in this question, you'll see that the barrel length is to 2 sig digs. So we should be writing this as 2.9 times 10 to the 3 newtons as our final answer.